Hi everyone and welcome to this video. In this video we are going to be doing functions and graphs of logarithms. Functions and graphs of logarithms. Okay, so to start off with, throughout this video what I'm going to do is I'm going to let a be a real number which is greater than 1. Okay, now I'm also going to define my logarithm function, and I'm going to use function notation since we've learned about functions already, and I'm going to say let f of x equal log base a of x. Okay, so when dealing with functions, the first question we want to ask ourselves is, what is the domain of the function? So in this case, what is the domain of f of x? Well, let me note firstly that this equation here, this function equation, it translates to the exponential equation, which looks something like this. It's base a, right, to the power of this number f of x is going to equal x. Okay, and that comes straight from the definition of logarithms, as you know. Okay, so what we have is here that f of x is some number. A, as I mentioned, is a real number greater than 1. Now, if you take any positive real number and you take it to the power of any number, positive or negative, is it possible that x can be less than or equal to 0? Right? No, it is not possible. So I'm going to say it is not possible that x is less than or equal to 0. Right? Whichever number you plug in f of x happens to be, if a is real and positive and greater than 1, then x is always greater than 0. So therefore, the domain is x is greater than 0. Okay. Okay, next I want to ask myself is, or perhaps first I should throw some axes over here. So I've got y and I've got x. Now, as I've just determined, the domain is x is greater than 0. So that means on this whole negative side of the graph, right, there's going to be nothing happening over there. Everything on the graph is going to be on this right hand side, since the domain is x is greater than 0. First thing I want to do is determine f of 1. F of 1, right, is going to equal, by a definition of the function here, log base a of 1. Now, this is going to correspond to a to the power of f of 1 must equal 1, right? Know your definition of logarithm, so it's a to the power f of 1 must equal 1. Okay, now, but we know that if a is a real number, then a, to get 1 on this right hand side, we have to take a to the power of 0. That's the only way this equation is true. So therefore, let me use black. So therefore, f of 1 is equal to 0. So therefore, the point x is equal to 1 and y is equal to 0 is on the graph. And that's the case, remember, for any a greater than 1. So I'm going to draw that point in the graph here. That's over here, 1, 0. Okay. Now to fill in the rest of the shape of this graph, so what I'm going to do is I'm going to consider two specific examples, right? I'm going to let f of x equal log base 2 of x, so I'm letting a equal 2, and g of x, I'm going to let a different base going to let it be log base 4 of x. Now, as I just determined, for both of these, f of 1 is equal to 0 and g of 1 is equal to 0. So we've got this point here, which is on that graph, whichever the base is. Okay, now let's determine some other values of x. Let's determine what happens if x is equal to 2. If x is equal to 2, then f of 2 is equal to log base 2 of 2, right? And sorry, not f of x, f of 2, g of 2 is equal to log base 4 of 2. Okay, now this is going to correspond to 2 to the power of f of 2 is equal to 2, and this is going to correspond to 2 to the power of the number, whatever the number is, g of 2 is going to equal, oh sorry, this should be a 4. 4 is my base, so 4 to the power of g of 2 is equal to 2. Okay, so that must equal 2. Now, the top one here, this is going to imply that, so here we can see that f of 2 must be 1. Okay, and here we can see that g of 2 must be a half. Okay, g of 2 must be a half. Okay, because 4 to the power of a half, that's the square root of 4, and that equals 2. Okay, so let's plot these points. So we've got x is equal to 2, so that's going to be somewhere over here, and then we're going to have f of 2 is 1, so let's just say that's here, and g of 2, I'm going to put g in green, and that's going to be there, where g of 2 is a half. Okay, and this one here is going to be 1. Okay, now that's if x is equal to 2. Let's now do if x is equal to a half. If x is equal to a half, then f of a half is equal to log base 2 of a half, which corresponds to 2 to the power of this number, f of a half, is equal to a half. Now this, as clearly we can see, is this implies that f of a half is equal to minus 1. And g of a half is going to be log base 4 of a half. So this is going to mean that 4 to the power of g of a half is equal to a half. And this is going to imply that g of a half must equal negative a half. Okay, so let me plot these points here. So I'm going to have x is equal to a half is somewhere over here, and then f of x, that gives me the point minus 1, so that's going to be somewhere over here, right? And g of x is going to be minus a half somewhere over here. Okay, so now we got to start to see a general shape. What you're going to have is this general shape of f of x looking like this. Okay, and g of x looking like this. Whoops. Okay, so this is g of x, and this one is f of x. Now we can see what's happening. This has a general curve shape, right? And we can see that where x is greater than 1, so on this side of the graph, we see that f of x is greater than g of x, and in this small gap here, we see that g of x is above f of x. Okay, so this is what the general shape of a log graph looks like, right? We see that the y-axis is an asymptote. We can get as low as possible any y value we want, but we will never touch the y value, because remember, we cannot have x is equal to naught. right? So this is what the general shape of a log graph looks like. Now, what I'm going to do is I use these two examples of a is equal to 2 and a is equal to 4, but in general, what we can say is that we're going to have the following. In general, if we have that 1 is less than a is less than b, right, and we say we let f of x equal log base a of x and g of x equal log base b of x, and then we're going to have a situation like this. So I'm going to let this be the blue line and this be the green line. We're going to have the blue like this and the green like this. Okay, and this point is of course the point 1, 0, because whatever your base is, the log graph is always going to cut at that point. This is of course my y-axis, and that is of course the x-axis, right? Now, if you understand the shape, that's almost everything you need to know about log graphs. There is a bit more to this, which I will still cover in this video, but this is the case where we have a is greater than 1, right? So a base which is greater than 1, and this is what the graph of f of x looks like. And this is how, if we have two bases, one bigger than the other, and then this is what the situation looks like. This is how you can see where one graph is above the other. Okay. Now, let's consider something else. Let's consider the graph f of x is equal to log. Now the base is a fraction, 1 over a x. So remember here a is still greater than 1. So if a is greater than 1, then what we have here is some fraction value less than 1. We also want to know what this graph looks like. Okay. By the same argument as above, we still have that f of 1 is going to equal 0, right? Because, right, I'll just repeat, we're going to have a base 1 over a to the power of f of 1 must equal x is 1, right? So let me just put in between here. So this will be like this, 1, and that must equal 0, right? Because here we have a positive number, even though it's a fraction, it's still a positive number. If we want take to the power of something, we have to take it to the power of 0 to get to 1. Okay, so we still have f of 1 is equal to 0. So therefore, 1, 0 is on the graph, just as before. And by the same argument above, we still have the domain is x greater than 0. And that's by exactly the same argument as above. Okay, so now if I draw my axis, right, I've still got this point here, right, and I've still got nothing going on this side because my domain is positive, strictly positive. Okay, but now how is the shape going to differ from these graphs over here? To do that, I'm going to consider again two specific examples. I'm going to let f of x equal log base a half x and g of x equal log base a quarter x. Now let's look at these graphs compared to each other. If x is equal to 4, then f of 4 is going to be log base a half of 4, which implies that 4 a half to the power of f of 4 must equal 4. Okay, so a half to the power of f of 4 is going to equal 4. Okay, so what's the answer to that? This implies that f of 4 must equal 2, or sorry, minus 2, right? So think about that. If you take a half to the power of minus 2, you're going to get, that's going to be 1 over a half like this squared. So that's going to be 1 over 4, and that's going to equal 4 as we needed. Okay. So then we have the point 4 and minus 2. Right. Now g of 4 is going to equal log base a quarter of 4, right, which is implying that a quarter to the power of g of 4 is going to equal 4, and then we can see that this implies that g of 4 is equal to minus 1, and then we're going to get the point 4 and minus 1. Okay, so let's plot these 2 points. Let's just say 4 is over here, right? And then f of 4, which is minus 2, let's say that's somewhere here, so that's minus 2, and minus 1 is going to be here for g. Okay, can you start to see what's happening? Okay, let's do another one, plot another point, and we're going to say if x is equal to a quarter, then f of a quarter is equal to log base a half of a quarter, right? So this is going to be a half, which is the base to the power of this number. F of a quarter is going to equal a quarter, right? And that must mean that f of a quarter is equal to 2, right? Because if we take half to the power of 2, we're going to get a quarter, okay, as we wanted. Okay, so here we have the point a quarter and 2, and you can do the same thing with g of a quarter. Let's just do it quickly. So this is going to be a quarter and a quarter. Okay, so this is very easy to see. This means a quarter to the power of g of a quarter is equal to a quarter. So that must mean a number to a power equals itself. That power must be 1. So g of a quarter equals 1, and here we have the point a quarter and 1. So where's a quarter on this graph? It's at about there, and then we're going to have f is going to be 2. So let me do that point in blue, and at g it's going to be 1. Okay, so now we can see here what's happening. We can have the same curved shape like this, right, with the y-axis being an asymptote, and for g we're going to have again y is the asymptote, cutting through that point 1, 0, but now going above the graph, right? So you can see what's happening. It's very similar to what we had here. So in general, in this case, if I draw my axes again, so I'm going to do the general case now, right? So again, we say we have 1 less than a less than b, and we're going to let f of x equal log base 1 over a of x, and we're going to have g of x equal log base 1 over b of x, right? I'm going to let this be the green and this be the blue, right? Y-axis, x-axis, right? This is the point 1, 0, and then let me draw it above the axis, right? And what we're going to have is that y asymptote, y-axis is asymptote, and then f is going to look like that, the blue, and g is going to look like this, the green. Okay, right. One more thing I want to point out. You will see that this shape, right, is very similar to this shape. right? So as it turns out, they're actually reflections about the x-axis, right? So I'm going to do one more set of axes here, and just to show you. So let's say we've got f of x. So again, we say a is greater than 1. F of x is equal to log ax, and let's say g of x is equal to log base 1 over a of x, right? F of x is going to look like this, and that's at the point 1, 0. And in this case, g of x was going to look something like this. Again, at that point 1, 0, y-axis, x-axis. And as it turns out, the last thing that I want to point out to you is that f and g are reflections of each other about the x-axis. Okay, and with that, that's the last thing you need to know about logarithm graphs, about log functions and their graphs. I hope you've absorbed this video. If not, watch it again. I'm sure if you ponder over it, it'll all make sense. But that's it. That's all there is to know about log graphs. That's the general shape. And that does bring me to the end of this video.